In this section, we'll discuss Boost, an optional set of WAN optimization features that requires additional licensing. Boost is a globally shared license and sold in 100 megabit or 10 gig blocks. Rules to consider with Boost is that Boost always works between a pair of EdgeConnect appliances, and it occurs within an SD-WAN overlay tunnel. Pass-through traffic cannot be boosted. As mentioned, a Boost license is required, and traffic is limited to the available licensed Boost configured in the EdgeConnect deployment. If traffic that is boostable exceeds the amount of Boost configured in the EdgeConnect, that excess traffic will not be boosted. As mentioned, Boost is two WAN optimization technologies: TCP acceleration, which mitigates latency, and network memory, which reduces congestion in the form of compression and deduplication of data. One of the most common network problems is high latency. Latency is the delay in the network, and the symptoms that are seen include an inability for the WAN routers to fully utilize available WAN bandwidth. The longer the delays in the network, the slower traffic moves. The longer devices wait for acknowledgements, the longer it takes to do things like transfer a file. Beyond a certain point, buying more bandwidth won't help you. You won't be able to fill the pipe because of the physics of the universe. One of the culprits here is the speed of light, 186,000 miles per second. The universe keeps us from transmitting data over a distance faster than light can traverse the same distance. This means the farther apart two endpoints are, the longer the inherent latency is. Additionally, hop-by-hop propagation delays introduced by equipment processing overhead in the transmission path add to network latency. Finally, loss and congestion can give the appearance of latency, since they slow things down because of lost packets, acknowledgements, and the resulting required retransmissions. TCP acceleration can't change the speed of light or eliminate processing delays, but it can help to reduce the effects of latency in your network by acting as a TCP proxy. Here is a laptop accessing the file server on the right. Latency round trip would be 2 plus 150 plus 2 milliseconds on the return for a total of 308 milliseconds. The EdgeConnect acts as a TCP proxy on behalf of the remote device, acting as a sort of man in the middle in the TCP session by acknowledging packets within 2 milliseconds, which allows the laptop to send packets much sooner. The LAN device can transmit as fast as possible, reducing round-trip time down to 4 milliseconds. Utilizing disk caching as well as forward error correction and packet order correction, the EdgeConnect ensures reliable connectivity between itself and the remote EdgeConnect, avoiding the need for retransmissions. TCP acceleration has to happen between the same pair of EdgeConnect appliances because they need to keep track of sequence numbers in the TCP session. This is all done using high-speed TCP. Acting at the TCP layer, this acceleration modifies network behavior in 4 key areas. Window scaling, which allows EdgeConnect appliances to expand the size of the TCP transmit window by a factor of over 250 compared to a standard device's TCP stack. Doing selective acknowledgement, which reduces the number of retransmissions in a lossy network environment. Doing accurate round-trip time measurement to allow the EdgeConnect appliances to more precisely adjust the acknowledgement timers. And high-speed TCP, reducing wasted transmission bandwidth by allowing the appliances to continuously transmit at the available capacity of the device by accurately judging where loss occurs due to congestion, unlike devices with a standard TCP stack. Running out of bandwidth on your WAN links can cause problems like dropped packets, along with the response time and connectivity problems that go with them. Users might complain of application slowness. Your storage replication targets might not be met because you can't push data to your backup sites fast enough. Sites and applications that used to work fine might begin to falter as growth in your network begins to saturate existing WAN links. EdgeConnect can help free up bandwidth with its network memory technology. The network memory features of Boost involve the deduplication and compression of transmitted data to reduce bandwidth requirements and congestion. EdgeConnect uses disk caching technology to perform deduplication. Deduplication essentially reduces the amount of bandwidth needed by eliminating repeated strings of data and locally caching frequently accessed data. Deduplication and compression include byte-level data reduction techniques for reducing data sent onto the WAN. In conjunction with utilizing Lempel-Ziv compression techniques, network memory dramatically reduces congestion in your network. This happens in 2 passes. Let's say I've got a Word file that's 75 megs. On the first pass, the file is sent to the EdgeConnect and it is not cached. The laptop sends the data file to the EdgeConnect, which parses the incoming packets in real time for common sequences of data. It fingerprints and stores that data for each sequence in its local disk cache, along with a fingerprint to identify that data in the disk cache. It compresses and transmits that data across the wire to the remote appliance. The EdgeConnect on the other side decompresses the packet and creates fingerprints as well. That file is then forwarded to the host. The next time the EdgeConnect sees the same sequence, any differences are fingerprinted. So let's say I find a typo in that Word document and it's simply just adding a period to the end of the sentence. Well, a majority of the file is exactly the same except for that change. We know we have the fingerprints for that exact set of data, so we fingerprint the new data, and instead of sending the entire 75 meg file, we just send the new information along with fingerprints, which are much, much smaller. The EdgeConnect on the other side receives that, replaces the fingerprint data with the actual data it has in its cache. It fingerprints that new data as well, and what the host on the other end receives is the updated file, without having to send all 75 megs. As you can probably infer, that may have been less than a meg or even a few hundred kilobytes for that period. Key thing to remember with network memory is that deduplication cannot work with encrypted traffic. In such a case as that, you will need to install certificates so that the EdgeConnects can act as men in the middle and decrypt that traffic. Remember our licensing exercise from earlier? We'll assume the same SD-WAN. Let's consider how much boost is required, assuming we want to boost 50% of the total network bandwidth and that all links are active. We have a total bandwidth used by the small branches, 10 times 30 of 300 megabytes, and boosting 50% of that gives us 150 megabytes. How much total bandwidth is used by the medium branches? 10 appliances times 80 for a total of 800 divided by 2 at 50% is 400 megabytes. And then the data center appliances will need to have 6 gigabytes boosted. So 6,550 megabytes is 50% of the bandwidth on the entire SD-WAN that we want to provide boost for. So how much boost is needed? Remember, they are sold in 100 megabit blocks. 6550 divided by 100 equals 65.5, which means you would need 66 blocks of 100 megabit boost. Let's go ahead and look at some review questions to further your understanding. In our next and final module, we'll look at the EdgeConnect SD-WAN reference architectures.